So Dean Minchillo is with the Texas A&M AgriLife Extension Center in Dallas, right at Coit, off Coit Road near the Georgia Bush Turnpike. And he's going to talk to us tonight about what's new in irrigation technology. So take it away, Dean.
All right. Thanks, Blake. Appreciate that intro. I don't really know what Blake's talking about. He's lived here in Texas long enough to know that we get crazy weather. I mean, come on, what's so unusual about 100+ degrees in May? I don't really see what he's saying. So anyway, yeah. So like he said, my name is Dean Minchillo. I'm AgriLife Extension Program Specialist out of the Dallas Center with a group that we call the Urban Wish Group, which is Water Innovation and Sustainability Hub. And my main focus is urban water. So pretty much anything to do with water in the urban setting. I do focus a little heavy on outdoor water use and water efficiency. Also dig into a little rainwater harvesting and blue-green infrastructure, which is like bioswales, rain gardens, and things like that for water quality purposes. And a little bit of background about me. I've been in the water conservation realm since really about 2000, I guess, when I first started with the Texas Commission on Environmental Quality, which was actually the Texas Natural Resource Conservation Commission, or the TNRCC at the time. And I started out there as a water rights permitter and writing permits for water rights, and then moved into the water conservation section and have been really doing that ever since. Just kind of moved around to some quasi-governmental agencies, and now at Texas A&M AgriLife, working for really the greatest folks of all, which are Texans. So thanks for being here tonight and for listening to all of this, and really just actually being here and wanting to do something different or learn something new, realizing that our water is pretty much a finite resource, as Blake said. We do have oh, and I do want to apologize. I'm kind of getting over a cold, so I still have some residual drainage and coughing going on. As wonderful as that is, so I may cough a little bit here and there, but I promise you I'm not contagious in any way. But as Blake had said, our water resources are pretty finite. We've got a lot of people moving into the region, and a lot of people coming from places where maybe they don't have issues with water, or maybe they're coming from places where they do have challenges with water, but they face them a little bit differently. So hopefully this isn't anything that's too elementary for you guys. Hopefully you learned some stuff. But what I want to talk to you about is kind of what's new in irrigation technology. And when I say what's new, I mean, it's stuff that's really probably come along in the last 10 or 15 years. We really haven't had a lot of like giant advancements in that kind of stuff. So let's get into it. And as far as your questions go, just throw them in the chat if you have questions, and we'll try to get them answered. I'm not really good at multitasking, so I don't know if I can type answers at you while I'm presenting at the same time, but we'll definitely have some time at the end of this to address any of your questions. So if you have something that's just burning, you can go and throw it in the chat and we'll get to it at the end. Or if you want to wait and you can ask questions at the end, then we can address those questions in a more verbal manner. So here's the outline for tonight. We're going to do a little bit of introduction and background. So we're going to talk a little bit about the history of lawn irrigation, just to give you a little background on that. We're going to talk about the Texas climate, as bizarre as it is right now. And then we'll talk just slightly about what is new in smart irrigation technology. kind of set the stage for that, and then we'll jump right into what I'm calling breaking it down into two basic sections, really. New controllers, which will be climate-based controllers or smart controllers, and then soil moisture sensor controllers. So those two types of controllers that are available on the market to us today. And then we'll talk about add-on sensors. And sensors are things that you can add on to your existing controller to make it more efficient. So if that works for everybody, let's get moving. All right, so irrigation information and background. This is irrigation's been going on for a really long time. So here's just a little timeline. Back in the really the early 1800s to the late 1800s, manicured type of lawns, or what is really known as the English garden per se, was really something that only royalty had, or people that were very, very wealthy. But in the 1870s, some of the municipal water suppliers started allowing the use of water hoses on personal property. And that really changed things, because now you've got a direct source of water right to your outside, to your lawn. And I don't really know when the hose was invented, but would imagine way before then. But it took a while for the municipalities to really, I guess, deem them safe for the public water supply, and that's when they started allowing those. And then really short after that, of course, we're opportunists, and in 1871, the very first patent was issued to something named lawn sprinkler. Now, there may have been other things that had different names that came out, but this was the first patent issued to something that was called a lawn sprinkler. And you can see a little image of what that patent looks like on the right. It's like a little maybe court jester kind of guy holding a hose and a spigot. And I'm assuming he spins around. That is probably the play with that, but not unlike what we have today for hose end sprinklers, really. So pretty ahead of its time. And when I say new technology, I mean the basic premise is still the same. We're just trying to get it more and more efficient as we go through time. And then in the 30s, 1830s, or I mean, that's actually the 1930s, that's a typo there. In the 1930s, the first impact sprinkler was invented. And y'all know the impact sprinkler, the picture I just showed earlier on here, that's an impact sprinkler. Of course, there's the dance with the impact sprinkler. So that was actually developed for agriculture use, and that was a way to get a lot of water out over a big area at one time. So that really started to change the face of agriculture. And then the next real big thing was in the 40s and the 50s. After the World War, people started really moving out to the suburbs. More highways, more roads, more accessibility. And in those suburbs came houses with lawns. And that began the real true love affair with the current American lawn that we have now. And that really was a snowball on what was developed for sprinklers. We saw everything developed, as well as in-ground irrigation systems started to come into play during that time. So that was really, really a boom. So to today, 2022, gosh, it's already 2022, the EPA, the Environmental Protection Agency, estimates that 28 million homes have in-ground irrigation systems. So that is a lot of irrigation systems. And we'll talk a little bit about that. I actually did a program, and I might refer back to it, that you can go back and watch. That was an evaluation, like how to evaluate your irrigation system. And there's some pretty good information there if you're a little new to in-ground irrigation systems and you haven't seen that program yet. Maybe that's something you'll want to go check out, because I won't get too much into the weeds on on how it works, but we will talk a little bit about that. So just some fun photos. Here's the impact sprinkler patent design right there on the left of that of your image by Engelhardt did that, and Joseph Lessler was the guy who is credited with inventing the first lawn sprinkler. He was from Buffalo, New York, so kind of interesting. You wouldn't think that there's much need for watering or irrigation in Buffalo, New York. You'd think they get plenty of rain, but that's where he's from. And then, of course, you could see like an early oscillating sprinkler. Those are still really popular today and largely unchanged from that original design. The old tractor that ran along the garden hose. And they still make those today, so they're not quite as robust and cast iron as they used to be, but I'm sure there's some folks that still remember that thing running around the yard, and probably terribly inefficient, but it got the job done. And then in the upper right corner there is like an old irrigation controller or timer or clock. They have lots of different names, but this particular one had these little pins that you would push and pull to set when your irrigation times were, when you wanted it to come on, when you wanted it to go off. So very, very early days. And now pretty much everything is electronic, and we'll get into that. And then the bottom picture, just your typical pop-up spray head that is almost infinitely adjustable too. This one has a couple of different little dials on it you can see, where you can change the spray pattern from probably down to like a quarter or less of a pattern all the way to a full pattern. And you can also change the amount of arc that's coming out of it, or the distance it sprays, by adjusting those little wheels there at the bottom. So pretty good, much more advanced than what we obviously had in the early days. Now we've got lots of pressure regulation that occurs right at the head. So really simplified just a lot of things, and any number of spray patterns to meet almost any need that you would possibly find in the lawn. But even with that technology, there's still a tremendous amount of waste. A lot of it comes from overwatering or from broken components, as just convenient as a in-ground irrigation system is. It's not without its headaches and problems, as some of y'all may know. Plus, it's for like a new homeowner who has never had an in-ground sprinkler system before, it can be quite eye-opening as to how much water it'll actually can use. So there's quite a bit to learn about them, but they're not trouble-free. Absolutely not. So like Blake said, just talking about the weather. Texas is a big place. It's huge. And we actually have 10 different zones across the state of Texas. These are all like little geographic regions, from the Blackland Prairie, which is pretty much where we are. And it gets its name from the soil that we have, which is really Texas black clay is what it, or Houston black clay is what it's called. And some people call it black gumbo, but it's black and it's heavy and it's clayey and it's gumbo-y, and it is really, really, really hard to dig in when it gets dry, and it's hard to dig in when it gets wet. So there is just a very small window of opportunity to really work in that soil good. But it is present throughout this whole pretty good swath of Texas. So at least a good swath of Texas where the majority of our population exists. And if you look at these little ecoregions, you can see kind of how our precipitation averages across the state really play into those eco-regions as well, from the Trans-Pecos or almost desert-like through the high plains into the piney woods and the Gulf Coast into the eastern part of Texas. So, and that makes a huge difference with plant selection and irrigation selection. So, of course, the picture on the left there is decomposed granite, some kind of succulent type of plants. That is really what landscape is available to you out in the far reaches of West Texas, where there's very, very little rainfall. And it seems like you get all of that rainfall in one day over there. And then, you know, of course, that continues into Arizona and southern New Mexico and then into parts of California. Whereas in East Texas, you get this on the right. You've got lots of different plants that you can grow, flowers, green grass, and you really don't need to irrigate it that much because the rainfall is pretty high. And on average for the state, or for our general region, we get about 33 inches of rainfall a year. And that's enough rainfall to really not have to water as much as we do. We've kind of gotten into this mindset or this habit of supplementing our irrigation with rainfall, and we really need to reverse that trend. We really need to be supplementing rainfall with our irrigation. We need to kind of let Mother Nature do its thing. The plants really love that rainwater way better than the highly treated drinking water that comes out of our sprinkler systems. So, and of course, there's the ever-present drought. So, and it's been said a number of times that we are living in a constant state of drought broken by periods of rainfall. And I think we are coming out of one of those periods of rainfall and maybe slipping back into some pretty significant drought conditions. 2007, I believe we had some pretty aggressive drought conditions, and then 2011 we had some pretty some pretty good drought conditions at that point. But it's been pretty good since then. Like we've been with really mild weather and lots of good rainfall. But as you can see with this drought monitor, and this is the latest one that just came out on the 10th. There'll be a new one that'll come out this coming up Thursday. Every Thursday, the new drought monitor comes out, and it really looks at soil conditions and then makes estimates based on rainfall and temperature outlooks. And you can see the really dark maroon color. That is exceptional drought. That is almost the worst that you can get. That is very, very dry, no soil moisture whatsoever. And you can see there are parts right around us that have no drought whatsoever. And that's basically because of the recent rains that we have had, which have been wonderful. Don't ever look a gift horse in the mouth, right? So take those rains when we get it, because it really fills up those lakes, and we really do not want to go into summer with our lakes depleted. We really want to go into summer, especially the prediction of being below average rainfall and above average temperatures this summer and El Nino conditions. We really want to go into that with as much water in our reservoirs as possible, because that is our source of drinking water. And for those of you that are here that haven't been through a pretty significant drought in Texas, the drought, when the lake levels drop, that'll trigger what is called a drought contingency plan. And every municipality, every water provider, every entity has a drought contingency plan. And this plan can also be called an emergency management plan, but the drought contingency plan basically allows, it's an ordinance. It has some finable offenses in it, but what it does is it allows a municipality to reduce water use or to have its water customers reduce their water use. And one of the number one uses of water in the summer by 60 to 70% is outdoor watering. Hands down, that is the most highest use of residential water. So what they end up doing is reducing that outdoor water use. So we'll go into restrictions of maybe no more than twice per week watering, maybe even more severe than that, no more than once per week watering. Or if we even get more severe than that, it could get stretched out to one watering every 2 weeks. And we'll talk a little bit more about that and how new technology helps and doesn't help with those types of conditions. But we need to keep that on our radar, and the more efficient we can be with our outdoor water use, the better off our plant material is going to be when we're going through heavy drought conditions, and the better off our water supply is going to be. So it's a dual win for sure, and it helps everybody out when we're efficient. One of the things that we'll see too is this kind of stuff going on. We'll see watering during rainstorms. We'll see massive amounts of runoff where overwatering, where watering is just running out of the soil, out of the grass, and onto the curb and down the street. Or watering when it's really windy. All these things are bad. So obviously watering during a rainstorm, that's a tremendous waste of municipal water. Let Mother Nature do what Mother Nature's going to do and replenish that soil moisture from the skies. And then with irrigating in the wind, it just pushes that water out. It blows the pattern apart. It pushes the water out into the atmosphere, and you lose a lot of it to wind drift and to the atmosphere just through evaporation, and very little of it actually reaches the soil surface. And when we're talking about above ground irrigation like this, we're already talking about a really, really low efficiency rate. We're probably down in the 40s, 40% effective or efficient is what they call it. So you're already losing about 60% of what's coming out just to different environmental factors. So anything else we add into that, such as wind or watering in the middle of the afternoon when it's really hot outside, we're losing more to evaporation. That's not good. And then the runoff. So overwatering, running the sprinklers too long. Like I talked about before with our soils, we have this Houston black clay, and that clay soil is really, really fine particles. It's really dense, and the rate at which it will take up water is really, really slow. We're looking at like 1/4 of an inch of water per hour. And most sprinkler systems are going to produce 1.5 gallons of water per minute. So you can easily see, if you just kind of think about that, how fast the soil can get saturated. And then once the soil reaches saturation point, it just runs off out of the soil. There's nowhere for the water to go. So when we're running our sprinklers for 20 minutes, 30 minutes, all at one time, we're losing a lot of that just to run off.
Hey, Dean.
Yeah.
If you are on the call and you're not muted, if you could go ahead and mute yourself, we would appreciate that so it doesn't disturb the presentation. Thanks.
Yeah, a lot of commotion going on in the background. Sounds like fun, though, whatever's going on. All right, so let's get into a little bit of the technology, right? So this is kind of just a simple flow chart. We talk about smart irrigation technology, and then we kind of break that down into two sections of new controllers and then add-on sensors. And with the controllers, like I said earlier, we've got climate-based or weather-based or ET-based or whatever you want to call them controllers, and then soil moisture controllers. And then we have the add-on sensors. And with those sensors, you can add on soil moisture, rain and freeze, or wind sensors. And rain and freeze sensors should be on pretty much every irrigation system you come across. That's simple. They're really inexpensive. We'll talk quite a bit about them as we move through the presentation. But and it is also a requirement, a state law that says every new irrigation system that is installed since, gosh, I think like 2006 has to have a rain and freeze sensor installed on the controller. So if you recently had an irrigation system installed or recently bought a house that has an irrigation system in it that is newer than 2006 and there's no rain and freeze sensor, then somebody dropped the ball on that and it should have one. But lucky they are pretty inexpensive. So anywhere from really about 35 bucks up, depending on how fancy you want to get. But you can get a pretty simple wired one for pretty cheap. And even some of the municipalities or water providers, sometimes they will offer like a rebate or a coupon or something for those. You'll just have to check with your city and see if there's something available. All right. So let's kind of get into it here. Let's talk about new irrigation controllers. So we're going to talk about two types: evapotranspiration controllers, which I'll talk about what all that is at length, and then soil moisture. Now, I will talk a lot about the EPA WaterSense program as I go through here, because the EPA WaterSense program labels a lot of these smart irrigation controllers. They have the WaterSense program, which is a partnership program with the Environmental Protection Association, or the EPA, to label products that are at least 25% more efficient in water use than their counterparts. So, and they have lots and lots and lots of items. A lot of them are indoor water use items, so faucets, shower heads, toilets, appliances, so many things like that. But in the around 2012, I guess, the EPA started looking at outdoor irrigation and started labeling some of these controllers, these smart technology controllers, with the WaterSense label. So, and that's kind of where we'll stick with it, is based on that. So, evapotranspiration. How many of y'all have heard of that term? Maybe not. But I'll get into it here in a second. But let's talk a little bit about climate or weather-based controllers. And I kind of hazard to call it climate controllers or climate-based. A lot of people like to call that, but climate really is something that occurs over really long periods of time, like several decades, where weather is what's happening right now. And these controllers really operate based on what's happening right now, which is what makes them so cool and so interesting. So this essential premise is that the controller will look at real-time weather, being rainfall, being solar radiation, wind, humidity, and then plant coefficient, which we'll talk about in a minute, or basically how much water does the plant really need. And they crunch all that together into a formula that gives you a recommended watering amount. So we're not overwatering our plants, we're not underwatering our plants. We're really kind of trying to give it what it needs based on what it has received in weather, and what it needs based on how much water it is transpiring and evaporating out of the soil. And we'll talk about that shortly. So essentially, the EPA, or the Water Sense program, says that all these 28 million homes that have in-ground irrigation systems, if they all had a Water Sense labeled irrigation controller, we'd save 220 billion gallons of water, or 2.4 billion in water costs. So if you have really paid any attention to what's going on in the United States, we have a lot of really aging water infrastructure with our sewer systems, with our water transportation systems. Blake can certainly talk about that because he lives that life, but there's a lot of work to be done. There's a lot of need there. And $2.4 billion could really go a long way in getting some of that stuff cleared up and getting our water systems a lot more efficient on the front end before it even gets to the homeowners. So, and basically, what these controllers do is they just adjust how much water the system puts out, right? So, and we'll talk about it a little more to where it makes sense. But maybe it rained a quarter inch or half an inch of rain on Monday, and your watering day is Wednesday. Then maybe your system is only going to put out like a quarter of an inch of water to make up for the deficit in what was not received in rainfall, right? Or if it rains, an inch and a half, then obviously there's no need to water. So your system will turn off until the desired conditions come back for it to actually turn on. So essentially what we're trying to do is like what I said earlier, we're trying to use our irrigation to supplement Mother Nature, not the other way around, right? So we're trying to look at Mother Nature, take what it's giving, and then apply that to our landscapes. They're not perfect. There's a lot of different ways that these controllers measure these parameters and this information. The School of Irrigation in College Station, Texas A&M School of Irrigation, run by Charles Swanson and Dr. Guy Phipps, which I'll talk about again here in a little bit. They have done a tremendous amount of research on all of these different controllers. They test them over and over and over again. They test new ones that come out against old ones, and they've got a whole series of parameters and that they'll test these controllers against. And some of them perform really good, and some of them don't perform at all. Some of them overwater, some of them underwater, some of them just water at odd times, some of them don't really match up well with the climate or the weather data. So there's any number of things that can go on, and luckily that information is publicly available. So you're looking at a smart controller, then maybe that's a place you want to go and do a little bit of research. The other thing too with any of these smart technology controllers is the controller is really just telling the system what to do, right? It cannot fix anything that is bad. So if your irrigation system is not up to speed, maybe you've got mixed emitters where you're running sprays and rotors on the same station, or maybe your spacing is too far apart, anything like that. The smart controller is not going to be able to fix that. It's only going to do what it's told to do, and then when it tells the emitters to come on, that's how much they're going to put out. So if you've got a really rough designed irrigation system where you don't really have good watering coverage, that might really show up when you have a smart controller, because it's trying to use the minimum amount of water just what the plant needs. But those gaps where you're not getting water, those are going to start to show up in that case. So we need to keep that in mind. It is not a fix-all. for sure, but it certainly can be a start in the right direction. So, evapotranspiration. It's really, what, 2 words, right? So it's evaporation and transpiration put together. So evaporation is just what is lost pretty much off of the surface. So out of the soil, out of our lakes, out of our water bodies, it's evaporation, right? Everybody knows it's what comes out of your swimming pool in the heat of the summer. That's where that water goes. It just goes into the atmosphere. Transpiration is water lost through the plant. So plants have stomata on the undersides of their leaves. Those stomata open and close and will release moisture into the atmosphere. If you ever look at some of our native plants, let's say a Turk's cap or something like that that has like a really big leaf, you'll see in the heat of the day, those leaves will droop. And the plant will look like it is just dry and it is dying. And the tendency would be to water that plant. But really what it's doing is it's closing its stomata. It's not releasing or it's not transpiring. It's going into like a little protection mode. It is protecting itself from the heat and going into a survival mode. And as soon as the weather starts to cool off, like in the evening, you can go look at that plant and those leaves will be perked back up again. So that's transpiration. So we put those 2 things together and we get evapotranspiration or ET. And then we'll even break it down a little bit farther into ETO, which is the estimated evapotranspiration of a plant. And that is how these smart controllers work. And like I mentioned, to get ET, we need to have these different parameters. So we need to have temperature, we need to have humidity, we need to know wind speed, because on like hot, windy days, stuff dries out a lot faster, right, than it does when the wind is not blowing. And we need sunlight or solar radiation. And then we need to know the plant type. So because different plants have different water needs, and we'll talk about that a little bit. But those are the things that we need to come up with ET or evapotranspiration or ETO. So these are kind of basically a weather station. It gives us all of this data. And the Texas ET network crunches all this, and that's a little bit later on here in the presentation. But these are kind of what these sensors look like. I mean, they're not crazy, huge or different, but this is also the same kind of information that meteorologists are collecting for weather data and for forecasting weather based on historic information. So I just kind of wanted to show you what this stuff looks like. But it takes all of these elements, and they're all crunched together into a formula, which is called the Penman-Monteith equation, which we'll get to in just a second. But so I mentioned crop coefficients, and this is basically coefficient. It's a term that has been developed from agriculture, right? So when we look at heavy agriculture, we're talking about crops, so corn, wheat, cotton, sorghum, whatever you want to grow, right? Legumes, all these crops use different amount of water. So to be more efficient, a bunch of scientists with really big brains have just looked at how much water is really lost through the plant and through evaporation. So that is what we call a crop coefficient. And it's essentially how much water does the plant need over a certain period of time to stay healthy. So the way this is done is they use a reference plant, which is like a tall fescue grown in perfect conditions. And they use what's called a lysimeter, which is a thing that weighs the soil in the plant. So it weighs the weight of the soil and weighs the amount of moisture in the soil. So it's telling us by the weight of the soil how much water is being lost through the plant. And that is how we come up with this crop coefficient. So typically here we have warm season grasses, right? So we have St. Augustine's, we have Bermudas, we have zoysias, we have buffalo grass, we have those different types of turf grasses. Those are all warm season turf grasses, and they're called warm season turf grasses because during the warm season, or like now, it's growing like crazy, right? It loves warm weather. Once the soil temperatures get up into that 80 to 95 degree range, right, then the turf grass is really thriving at that point. That's when it is happiest, whereas a cool season grass thrives better on the cooler season. So in the spring and the fall, you'll see excessive growth on that type of grass, but during the summer when it's so hot, you'll see a real decline in it. That's why we cannot really grow cool season grasses very well here without a lot of inputs, a lot of attention, a lot of babying, a lot of water. So we need to, so we're going to focus really on warm season turfgrass, which is a crop coefficient of 0.6 or 60% replacement. Now, cool season has a higher coefficient. Obviously, it needs a little bit more water because of the nature of the turfgrass, but we can use that cool season turfgrass on some type of turfgrass that has a high stress. So let's say a sports field, right, that's mowed really short and gets a lot of like foot traffic on it, or a dog park that gets a lot of dogs running on it, anything like that. Soccer fields, those are going to be a hybrid type of Bermuda grass, high stress, and that's going to take more water to actually keep that quality up. So that's kind of the science stuff behind crop coefficient and what goes into this calculation right here, the Penman-Monteith equation. So if you want to jot that down, go for it and start plugging in your numbers, see what you come up with. I don't even really know where to start with that. So it's a crazy formula, but lucky for us, all this is already done. It's already done for us. And a place where you can go and get all this information is your smart controller, right? It's going to take care of a lot of this information for you. You're just going to hook it up, plug it in. It's going to ask you some questions. You're going to have to go through, and talk about what type of plant material you're watering, what type of slope you have, what type of soil, and then you're going to have to put in information about your watering schedule, and that we'll talk about too as well. But if you don't have a smart controller, or you're not ready to use a smart controller, but you still want to get the benefits of watering based on evapotranspiration data or weather information, you can go to the Texas ET network. It's free to everybody to use. And you can go in there and it has historic weather data. It has current evapotranspiration data for all of these different regions in Texas. You can see the little map there with all those red points. Those are all weather stations that are run by the Texas ET network that are collecting that information. But the easiest way to do it is to create a profile. And I think I created a profile. Yeah, so I just took some screenshots. I just created a little profile just to kind of show you what it looks like. But this is the easiest way to do it. So I work at the Dallas Center off of Coit Road, the AgriLife Extension Dallas Center, which is half of it is in Plano or Collin County. The other half is in Dallas County. So I think the address is technically Dallas, but like 2 steps one direction and you're actually in Plano. So I selected the Plano weather station. And so I'll have a drop-down list of all the different stations that are near you. So you want to pick the station that is closest to you so you can get the most accurate weather information for you, right? And then you're going to have your plant coefficient. And again, this tells you what those plant coefficients are. We're going to go with with warm season grass, which is going to give us a 0.6. And then we have what's called, they're calling it allowable stress factor. I've heard it called a quality factor before. It's essentially how well do you want the grass to do, right? So if you do 100%, then that's like crop kind of stuff. That's like yield where you want to harvest the grass. We obviously don't want to harvest the grass. We don't want to be out there mowing all the time, but we don't want it to look terrible either, right? We want it to look good. So we're going to go with like a 60% allowable stress factor. We're going to let it get to about 60% stressed before we water it again. So we're giving it a little bit of a hard time, but we're keeping it looking good and looking healthy. I want a summary of the weather conditions over the past 7 days because I'm going to water weekly, right? So I may water twice per week, I may water once per week, but and my watering days are going to be like Wednesday and Saturday, let's say, or Wednesday and Sunday maybe. So I want to get that information sent to me before I actually water, so I know what it is. So on this, I selected Tuesday for the day to receive my information. So, and then you put in all that information, and then every week you get an email on whatever day you selected. And this has the information here on it. So this is basically what it looks like. This is my account. This is the Dallas Center, is what I named my site, and it's in Plano. This is, and I can add other irrigation sites or landscape sites. So if I've got other things in the area in Plano that I want to do, I can add them to those, and it's going to give me recommendations for all of those sites. So this is kind of what the email looks like that you'll get right here. So basically, it's just going to give you a watering recommendation. So with this selection that I did, based on the weather that we've recently had, my watering requirement is 0.87 inches of water. So less than an inch of water, and that's with a plant coefficient of 0.6, warm season turf with a stress factor of 60%. And the amount of effective rainfall that we receive is 1/100th of an inch. So that's a tiny amount. That doesn't even register on the radar. So the big question here is, how do I know how much 0.87 inches of water is? Well, it's not easy. It takes a little bit of work. But if you go back and to the archives and you look at the presentation that I did for Upper Trinity a few weeks ago called Evaluating Your Irrigation System, I actually talk about that. I talk about how to do a catch can test or a meter method test to find out your precipitation rate of your irrigation system, and then you can use that information to know how much in 0.87 inches of water would be. So essentially, I just talk about how to program your system based on 1 inch of water per week, and then use your seasonal adjustment on your controller to make the adjustments based on these recommendations. So that's the easiest way to do it. That's the way you're going to really be able to utilize this information. And a lot of times you would really be surprised how often it's going to tell you that no irrigation is required. You may think that that everything's pretty hot, it's pretty dry, hasn't rained in a little while, but actually you would be surprised that you can skip a week with irrigation with very little damage being done to the turf grass. So, and all of this is rooted in science. None of it is witchcraft or anything or just made up. It is all tested, tried, true, and works. Now I will say though, if you're going to go into a program like this, if you already have a very, very stressed out landscape, very stressed lawn due to soil compaction or other issues, then you probably want to get those issues alleviated before you go into doing some kind of program like this, because you really are just kind of just skirting the line as to how much water you're giving your landscape. But we're helping our plant material by not overwatering. We're helping the environment by not overwatering, and we're saving some water as we by not wasting it, right? So bottom line is we don't really want to waste that water. So that's kind of small, so I just blew it up a little bit for you so you can get a better idea of what that's going to look like. But yeah, so this is my site, the Dallas Center, and this would be what I would water for the week. Now, if I'm doing 2 waterings a week, then I'm going to break that up to it's 87, so I'd probably break it up to 43. 0.43 inches for each watering. So that is for the entire week. So I would break that to, essentially less than half an inch each time I water. So, so the other thing though really is like how you're watering, right? The smart controller is going to take into account all the information that it possibly can to give you the best information based on current conditions as far as weather goes. But there's also a cycle and soak method of watering that is going to push the water down into the soil deeply. And I talk about that also on that previous one, and maybe Blake can link to that for you guys, or throw it in the chat or something, and throw you the link to go back and watch that webinar on that. So there's a lot of good information on that one that relates back to or ties into this presentation really, really well. Okay, so I hope we're doing good. I hope we're doing all right. I don't see any questions in the chat, so I don't know if that's good or bad, but maybe you guys are all just holding on to those questions and you're going to just bombard me later with it, which is fine. You can do that. All right, so let's move to soil moisture-based controllers. Okay, so before we were talking about weather, right? And we were talking about evaporation and transpiration from the plant. We were talking about humidity, rainfall, solar radiation, and wind. So all of these elements that are fairly measurable on the surface, but excuse me, but we're not really looking at exactly what the moisture level is in the soil. We're making some scientific estimations based on what we know from our crop coefficient. So now we're going to actually look at what's going on in the soil. So a soil moisture sensor uses just that. It uses the volumetric water content that's in the soil. So the soil, especially our clay soil, is like a sponge, right? You pour water on it, the sponge absorbs it, and then it starts to dry out. If you take a big, thick sponge and you fill it up with water and you set it outside on the sidewalk, it's going to dry out kind of layer by layer, right? That top part that's exposed, that's going to dry out first. Then the middle layer is going to dry out. Then the lower layer is going to dry out until eventually the whole thing is dry. That's sort of the same thing that's going on in our soil, right? But what the soil moisture sensor does is it tells us how much moisture is in the actual root zone of the soil. And the root zone, right, is where the plant's roots take up moisture and nutrients. So that's obviously where we want the water. The deeper we can get the water and the roots down into the root zone, the more protection we're going to have from drought. So key is watering deeply, using our cycle and soak method, and using the right amount of water and getting it down into the soil to where we're not actually starving our plants at all. So again, the EPA has some estimates on how much water could be saved through the use of soil moisture sensors. So 15,000 gallons of water a year. So I mean, not quite as much, as with the weather-based controllers, but still pretty good. And again, so basically the way these work is you will, as the user will input a certain percentage of soil moisture to be depleted out of the soil. And at that point, when the sensor determines that the soil is X amount of dry, then it will allow the irrigation system to come on and it'll run for however long it needs to run to replenish that soil. So we call that managed allowable depletion. Again, something borrowed from agriculture and that we're applying to our residential yards. And it can be pretty good, it can be pretty useful, but it also can be a little bit tricky. Managed allowable depletion or allowed depletion, MAD is what we call it, is generally you want to keep a little bit of, I guess, freeboard cushion in your soil moisture level so you don't run it completely out of moisture. So you probably want to keep it somewhere in that range of 10 to 40%, depending on how much the plant can actually sustain or what type of plant is. If it's like a woody perennial and native plant, like a lantana or a salvia or sages, they can get down pretty low. You could probably take those down to 10% and not really have any problem. If you've got some other more sensitive plants like hostas or hydrangeas or something along those lines, then you probably don't want to take it down that low and stress them out too much, right? So it's kind of similar to, like, just think of it as like the gas tank in your car, right? So when you're going to drive, but you're not going to drive so far to where it just completely runs out of gas and then fill it up, right? You're going to get down to a certain point, you're going to get down to a quarter tank, and you're going to start thinking about it. And then you're going to look and you're going to see what your range is. And then you're going to question that. You're going to be like, oh, is that really right? Then you're going to get down to an eighth of a tank of gas. Then you're definitely going to stop and fill it. You're not going to tempt it. But so you're going to leave a little bit of that freeboard in there. And just like your car, you have a little reserve built in. So generally empty doesn't mean totally empty. And they do that to protect some of the sensors and fuel injectors and things like that. Plants are not quite that technologically advanced, but they will like go into protection mode as much as possible, and that's them wilting. And the surface of the plant may be completely dry and may die, but the root structure may still actually be just sipping on whatever moisture it can really get. However, when we talk about watering restrictions, and if we go into a heavy water restriction where we're talking once per week watering, or maybe even once every 2-week watering, the soil moisture sensor is not going to be the ideal candidate, because we're really going to have to force it to go in our landscapes to go into deficit mode. We're going to have to go past that point of depletion in the soil if we're stretching it out to 14 days, and then it's going to run forever to try to fill up that soil profile. So not the most ideal thing to use, especially with watering windows and extreme drought conditions. So here's just kind of a little chart to give you an idea of what we're talking about with root zone. So at the top there, you can see that navy blue, that's the saturation point. That's what they call full, right? It's field capacity, it is totally saturated. The soil is absolutely completely filled up. So then you let it go down a little bit till you get to that 40 to 50% maximum allowable depletion, right? You can drop that down even lower, get it closer to that permanent wilting point, but you're kind of sticking right there in the middle. letting the plant stress just a little bit, and then going and filling up the water in that root zone. Again, not ideal when you're looking at like long-term deficit watering going over past the 7-day period, because the system is really going to be calculated on kind of a 7-day weekly basis. That's how these soil moisture sensors work. You can even program them to where they just, as soon as it hits a certain threshold, it comes on and waters regardless of what day it is of the week. But with our watering restrictions, you're usually limited to 1 or 2 days per week when you actually can water. So you've got to get it to hold off till that particular watering day when it's available. And if the soil is depleted enough of moisture, then the system's going to have to run a really, really long time to fill that reservoir back up, that soil reservoir back up to the point. So, and that may stretch out beyond whatever your watering window is. Pretty much every municipality across the Metroplex has a prohibition on watering between the afternoon hours. So really like 10 to 6 or 11 to 7 or something like that. So pretty much everybody has that ordinance in place that says no watering between those times. And that makes sense because that's the heat of the day. We're really losing a lot of water to evaporation and wind at that point in time. So I hope that kind of helps explain that a little bit for you, gives you a little more of a visual on what watering frequency and maximum allowed depletion is. So we talk about soils, and I talked about our clay soil having a low infiltration rate, but it has a low infiltration rate, but it has an excellent soil water holding capacity, right? If you look at this chart, you can see sand has a very, very low water holding capacity, whereas clay has a really, really high capacity. So if we can get the water into the soil and get it down deep enough in like 6 inches or so, where that really effective root zone is, that's where we want it, right? We can get about 1 inch of water available down there at a 50% maximum allowed depletion. So 1 inch of water in the soil is definitely enough to sustain warm season turf grass for over a week period of time. So now when we look at, or when I mention that you really don't need to water after you've received some rainfall, or even if you haven't received rainfall in a week or so, you still have that good amount of water built up, that good amount of moisture built up in that clay soil, right? And if our soil is not compacted, if our soil is nice and has lots of microbial activity in it, good microorganisms, maybe even some compost in there prepared for it before the sod was put down, and you're going to have a nice spongy clay soil that's going to really absorb a good amount of water. So again, we want those deep roots, right? We want to get those roots down deep into the soil, and we're going to do that by, when we apply our water, we're going to water smart, right? We're going to use cycle and soak techniques, and we're not going to water every day, right? Because that's going to encourage short root growth, because the water is always going to be at the surface of the soil. So we're going to try to stretch those waterings out to no more than twice per week. And then we're going to water deep whenever we do water. We're going to get that water down deep into 6 to 8 inch profile of our clay soil. And we've got plenty of that in most areas in the Metroplex. We're plenty deep. So we shouldn't have much of a problem at all getting it down in there. And like I mentioned, when we go into watering restrictions, it's really, really hard to produce like these good science-based irrigation schedules, because if you're using a soil moisture sensor, it just wants to water whenever the soil gets depleted, right? And it can't when we have a watering schedule, because you may get depleted the soil may be depleted by Thursday, but your watering day is really not until Sunday. So now you've got a couple of days you've got to wait before you can actually water. And you've gone into a deficit situation beyond stress. So now you've got to really put a lot more water on the soil to fill up that soil profile. So keep that in mind when you're thinking about using soil moisture sensors on your irrigation system. As far as smart controllers go that have the EPA WaterSense label on them, there's 971 weather-based irrigation controllers out there that have the WaterSense label on them. And those all come from 24 manufacturers. So when I say there's 971, I mean, there could be like one controller, like let's just say a Hunter controller may have 4 or 5 versions of the same controller, and they may all be listed here, right? So you may have like a Hunter whatever 3 station, a Hunter whatever 6 station, a Hunter whatever 9 station, 12 station, and each of those are going to be labeled on here. So it's not just the Hunter whatever, it's the Hunter whatever plus all these different stations, or the Rainbird whatever plus these different attributes to it. So that's why there's so many of them. But you can go to this website, look for WaterSense, epa.gov/products, and you can run through the entire list of every one of the products that you want. They have a massive spreadsheet on there. You can look at all of them. You can also compare all of these on the School of Irrigation. You can go there and you can look at what type of research was done on the controller, what kind of testing was done on it, and where it ranks in their estimation of being good or not meeting standards. Right. So, and then for the soil moisture based ones, that's still really, really new technology for the residential landscape. So we're really looking at only 4 controllers from 2 manufacturers. So 2 different types of controller from each manufacturer. So not a lot going on there, but I would suspect that is going to increase as we continue to get better with technology on all of that. But I encourage you to go and utilize this WaterSense website, even if you're just doing some remodeling in your house and you're getting a new shower head, you're getting new toilets or whatever. Go and look and see what's available with the WaterSense label on it, and maybe save a little bit of water with some upgraded fixtures. All right. So we're doing pretty good, moving right along. This picture here is Mr. Charles Swanson in his laboratory of all these crazy controllers with all these add-on sensors. So this is part of the testing ground that they have. They have another indoor one as well, where they have lots of different types of controllers. But you can see the mad scientist there at work going through all of these controllers. So for anybody who has a fairly modern controller, digital controller, not one that's a rod and pin like the one I showed you much earlier in the presentation, you should be able to add sensors onto it, right? There's a couple of little places where you can wire a sensor right into the controller. I may have a picture of that here soon. But the main ones that we're going to look at, right, are going to be rain and freeze sensors. And I talked a little bit about rain sensors already, but this is going to be your #1 add-on sensor. This is going to be your best bang for your buck out of all the sensors. It's going to be a rain and freeze sensor, right? Then next is going to be your soil moisture sensor. A little more involved with this because this has to be buried in the ground. And there's not a ton of wireless options. There are a few, but it's something that really needs to be installed at the time the irrigation system is installed into the ground, or there's a lot of extra digging to get it to work efficiently. And then wind sensors, and I talked about how that is to irrigate the wind, and I'll probably repeat myself as we get to that. So So here you go. Here's the inside of the typical controller. You've got all of your colored wires there. Those are all of your zones or stations or control valves, whatever you want to call it. Those are all the different ones from valve 1 all the way through. This one has 9 stations or 9 zones. You wanna look at it, and then you see you have to look pretty close, but there's a little yellow box and it says sensor, and there's a little black wire loop in there. That little black wire loop, that's where you're going to plug your sensor into or wire your sensor into. If you have that little loop there, it doesn't mean you have a sensor somewhere. It just means that that little loop is just connecting those two ports. So that is pretty much where you'll wire it in. Super simple, super easy. And what these add-on sensors do is they just interrupt the irrigation cycle, right? They don't change the irrigation cycle. They don't do anything other than just interrupt it. So if with a rain sensor, if it rains, it's going to stop, not allow the irrigation system to run until it dries. Right, so same thing with the wind, same thing with the freeze, or same thing with the soil moisture sensor, except for a soil moisture sensor is going to work a little bit different, and we'll get to that. But bottom line is they're used to take a regular type of controller and increase its efficiency, make it a little bit better, make it a little bit more efficient, take a little bit more of the control out of your hands, and a little bit of the worry out of your hands. So if you're on vacation and it's pouring down rain and you know your system is going to run on Wednesday, if you have a rain and freeze sensor on it, you feel pretty good that the rain and freeze sensor interrupted it and it's not going to water now when you're gone, and your neighbors aren't going to come at you with pitchforks and stuff because you were watering in the rain, wasting water. And they're cheap. So generally they're really expensive, especially the rain and freeze sensors. And there's so many different ones. So here with rain and freeze sensors, again, they just interrupt the cycle in the event of like a rain or a freeze. So below 32 degrees typically is where it's set. Some of them you can adjust. If you want it up higher, if you want it to interrupt at 40 degrees or whatever temperature you want it to do. They come wired, they come wireless. They have different interfaces to them, but they have 3 different basic types, right? So one is a tip cup. So it has like a little cup inside, and when that cup fills up with a certain amount of water from rain, it tips. And when it tips, it triggers the electronic shutoff on there, and it shuts off the system until it dries out enough and the cup tips back up, or your controller has a time delay, right? It may not water again for 36 hours or something like that. Sometimes that's how they work. The other one that's popular is like a little dish or a tray, and same thing is like a tip cup. As that tray fills up with water, the weight pushes the tray down, and then it trips an electronic shutoff switch that interrupts the irrigation cycle from running. Those two, pretty dependable. The problem with those is they can get debris in them and give you some false readings. So you want to be careful with that. Maybe a little bit of maintenance every once in a while on them, clean them out. And of course, where you install these is important too. It's got to be out in the open where it can receive all the rain that is possibly going to hit it. So you can't put it underneath an eave. You can't do anything different like that. It's got to be it's got to be out in the open. And then the most popular one, and generally the most inexpensive one, is the one that has these little discs in it, which is kind of like the one that's there in the picture in the top right corner. It has these little clay discs, and when those clay discs absorb moisture, when they absorb enough moisture, they get heavy and they drop. And when they drop, they trip the shutoff switch, and that interrupts the cycle until those clay discs dry out. Then when they dry out, they go back up into position, and everything resumes normally the way it was. So Again, though, probably the most popular, the most reliable, but you have to pay attention to those. If you have a really, really, really old one, those discs can go bad. So you want to make sure that you test it every once in a while to make sure that it is still operating appropriately. And the main thing with these is just minimizing water waste, right? You don't want to water when it's raining out. That's definitely a faux pas. So and a lot of them you can adjust. So you can adjust them to how much rainfall it actually takes before it interrupts the cycle. You can do a 1/4 inch, 1/2 inch, 3/4 of an inch of rainfall, whatever you want, before it actually turns off the system. So we'll warn you though, if you set it for like 3/4 of an inch, you may be watering in a rainstorm before it actually turns off. So and lots of different options out there, just tons, from anywhere from like probably $30 up to 150 to 200 bucks on those sensors, just depending on what you want. Soil moisture sensors, again, a little bit more intensive as far as installing. Need to be buried into the ground and need to be buried in the right spot. So got to be in a spot where it's going to be really representative of what's going on in the lawn with nature. So you don't want it too close to a sprinkler head. You don't want it near like a downspout. You don't want it in a shady area where the soil's not going to dry out very fast. You want it in a good representative area that will maximize its efficiency. And the wired ones, right, that wire has got to run back to the irrigation controller. So you've got a pretty long run of wire and a pretty good trench you're going to have to dig. And if you're hydrozoned, your irrigation system is hydrozoned where you have your plant beds and turf grass and garden on different stations independent of each other, you may want multiple sensors, right? You may want one in your plant bed, and you may want one in your turf grass, and maybe one in your garden or wherever, right? So they do make wireless ones. They're not inexpensive, but there are a few of those out on the market that just kind of go onto the soil surface, and with these little probes, you can see this one at the bottom, and push it down into the soil. Battery life is probably pretty good on them, usually like around 10 years, so you don't really need to worry about that. But you do need to pay attention to where you put it. So if there's an issue with it, you can find it and the grass doesn't grow over it. So, but they're pretty big, so you should be able to identify where it is. And these are generally expensive, so these are not a cheap option like the rain sensors. This is going to be a little bit more of an investment in this system. So, and again, a technology borrowed from agriculture, right? So, and then again, here's the last one, wind sensors. These will interrupt during any kind of wind storm. Oh, and I forgot to mention on the soil moisture sensors, these actually will bypass the irrigation system, right, based before a scheduled event, right? So it's kind of reading and sending back to the controller a little bit different than after the fact, as like a weather-based controller is doing. So, so a little different on how it works there. But and then the wind sensor is just like the rain sensor. It's adjustable for a particular wind speed threshold. If you live in a place where the average wind speed is like 10 miles an hour or 15 miles an hour all the time, then you probably want to adjust it to be above that, right? So, and hit those wind gusts. A couple of different ones here. There's, kind of a simple apparatus that you can see. It has the dials on it, so you can adjust for the wind speed. So you can actually change it seasonally if you wanted to. Simple one there that just has like a mount and a rod that you wired into the controller. And then the one on the bottom actually is a wind direction and a wind speed. What do they call those? Anemometers, I think, or something like that. So anyway, pretty cool. If you're into weather, you might want to get something like that. And you can get like a whole entire weather station too. You can get a controller that has like a local weather station incorporated with it that you can mount on the roof of your house or somewhere. And it's usually not very big, like size of a shoebox or something. So you can even get those. They're questionable as to how well they work because you've got a lot of devices all in one little space. You've got your wind, your rain, and your solar radiation and humidity, all that stuff all in one unit. So there are some challenges there, but that is always an option for you if you want to do that and get like the most hyper local weather data for your irrigation that you absolutely can. And then low tech items, right? So these are two of the most basic items you can get and probably have the most benefit that you can imagine to them. A simple soil moisture sensor, that probe that you just stick in the ground and you can see where the soil moisture is. I have one here. I hope you guys can see this. And I just used a ruler and just marked off on there inches. So I know when I put it down into the soil, I know how deep the probe is, and I can see what kind of moisture level there is in the soil. You can use it for potted plants. You can use it for your turf grass. Just don't leave it in the soil because the little tip here will erode and then fall off, and then you don't have a working sensor. So, but a great way to just manage your moisture level in your soil. And then a simple rain gauge, right? If you get a rainstorm and you get an inch of rain in the rain gauge, then pretty sure you don't need to water that following week. You're going to have enough moisture in the soil to sustain you for the next week. So or even if you get half an inch, right, then maybe you only need to water it one time that week or half as much as you would have before or even less, right? So two really simple, low tech, very reliable items that you can get anywhere. These soil moisture sensors, you can get them at hardware store. I've seen them on Amazon, 2 packs for like $8. So super inexpensive. And then with the rain gauge, you can go as simple as fancy as you want. You can even just use a pocket can. Anything that has like a flat side, you leave it out in the weather. When it rains, you take a ruler, put it down in the can to see how deep it is, and then you know how many inches of rain you got. I don't know anything more low tech than that, and you got to drink the coffee out of it too, so that's even better. Here's some list of resources available. There's the first one there is irrigation. That's the School of Irrigation. That's where you'll find a lot of information on the irrigation controllers, the research that's done, the testing on the smart controllers, the Aggie horticulture. That's where you go for just general horticulture information. Texas ET Network, talked about that at length, and setting up a profile, which I can't urge you enough to do that. Just if you got the capacity, just do it and just kind of see what kind of information you get. It's kind of fun. Aggie Turf is a great place to go if you have turf-related questions. So they address weeds on Aggie Turf, different types of turf, watering requirements, lots of things. Answer all your turf questions there. Healthy Lawns, Healthy Waters is a program that I do that is a watershed protection program that has a pretty good rainwater harvesting component to it and a landscape best management practice component to it. So pretty good program there. You can go to that website and see when the next program is available. Rainwater harvesting, of course, we always want to do that when we can, save our water for a non-rainy day. And then the Dallas Center website where I work, which is dallas.tamu.edu. And then there I am. That's it for me. So it's my contact information there, my email address, and a couple of more websites if you want to get some more information.